Hi everybody, this is Mr. Schaefer, and I wanted to present an example of analyzing graphs of functions for you, and just to provide you with a walkthrough of information on how to solve these problems. So to begin, we have a picture, in this case, of a function, and we'd like to answer all these different questions about that function, just sort of a complete analysis of what's going on. So number 2a says to find f of -2 and then f of 4. Those are function inputs. And to find the matching outputs, I just want to go to the picture and see where the picture is at the address of, in this case, -2, and over here at 4. So it looks like at -2, the function output would be -1. 4 has an output of +1. So the inputs are the x and the outputs would be the y's. Now letter B is asking for the interval where f of x is greater than or equal to 0. Interval always means that we're going to use x's. So put a little note and draw a little x next to that word interval. So one thing we can do is just kind of think of this as a big picture. Where is this going to be above 0? Well, above 0 would be above the x-axis. If I shade or color this graph, where my function or where the graph is in blue would be above the x-axis. And then if I shade with a different color, I'll pick yellow, down here the function is below the x-axis and would therefore have function values that are negative. Remember though, to always go with respect to x when we're writing intervals. So the interval where f is positive is going to be from, it looks like -1 is that point right here, where we sort of break between the positive and the negative. So from -1 all the way up to infinity, we're going to have a positive function value. And let's actually bracket the -1 to include the -1, because I'm including 0 because of that greater than or equal to bar. -1 to infinity, the function is going to be positive. Negative, well, that would be, again, x values. This is an x value of -7, way down here. From -7 all the way to -1, that function is below the x-axis. So from -7, again, we'll include, let's include that -7. Oops. Try that again here. All the way up to -1. Now, domain and range. Domain left to right, x values. My leftmost x point is -7, and the rightmost x point just goes on to infinity. So -7, again, we're going to include -7, so put that, or use a closed bracket around it, and then go up to infinity. The range is the y value. I want lowest to highest. Lowest is -6. That ordered pair right there is -7, -6. But the range would be the y values. Those are the ones that I want. So -6 on the low end. Struggling to write that there. There we go. And then how high does this function go? Y value, again, up to infinity. So we'd say -6 to infinity would be the range. Now, for what values of x is the function equal to 0? So scan the function for any x-intercepts. That's what that really means. When the function is equal to 0, we're looking for x-intercepts, or zeros of the function. Looks like -1 and +3 would be the two x-intercepts. And then we come to this question that talks about increasing versus decreasing. Now, what I kind of like to do is just draw arrows on my picture. So in fact, what I might do is come down here to this other graphic, same picture, but it's just a little bit cleaner. So remember that we read graphs the way that we read books. We read books from left to right. We're going to read graphs also from left to right. So as I read this graph, from left to right, the graph is increasing from -7 right there, all the way over to, looks like all the way to 0. Function is increasing right there. Then it's constant, it levels out, falls, decreases a tiny bit, and then continues to increase past the number 3 right here. I'm drawing little arrows to show the direction of the graph. I'll switch colors to show a decreasing part of the graph, which is right here, a little spot. And then I'll change colors one more time to show a constant. There's a constant or level, horizontal part of the graph as well. Now, let's go and mark down where all this stuff happens. So let's begin with increasing. And remember that intervals always mean x numbers. I want to make sure I look to the x-axis for the values as kind of the address of where these things happen. So left to right, increasing, -7 all the way to 0. -7 all the way to 0 would be increasing, but it's also increasing from 3 up to infinity. So I have two intervals where the function is increasing. Decreasing, 2 to 3, the function is falling. And then constant, again, x numbers, 0 all the way across to 2. The function is constant. Absolute maximum, absolute minimum. Think of absolute maximum as kind of the Mount Everest of your entire function. Value, though, be careful there. The value means y coordinate. And where it occurs, that would be the x coordinate. Now, in this picture here, there is no absolute maximum. It just goes on to infinity, so none. Absolute minimum, well, way down here, that sort of starting point there has a minimum value of -6 occurring at x equals -7. The value is the y, which is -6, and it occurs at the location of x equals -7. Don't confuse those two numbers. And then finally, I'm going to end here with, I'm going to skip down to letter I. For what values of x is the function equal to -1? Think about an intersection. Circle that and write the word intersect. Intersect the line y equals -1 with my picture right here. If I did that, here's the line y equals -1. It would come right through here. I'll label it. For what values of x is the function equal to -1? We'll basically find where those two intersect. Looks like right there at x equals -2. There could be another solution. In this case, this function only has one place where that horizontal line intersects the function, x equals -2. And then lastly here, end behavior. We like the word limit. And the abbreviation mathematically is just LIM. The limit as x approaches -infinity would be one end behavior. So just travel to the left forever on your function. If I travel left forever, I'm actually going to end down there at -6. And these limit values or these end behavior values are going to be function values. So that's a y value. And then finally, how about the other end? We always have to test both ends. So the limit as x approaches positive infinity again of the function would be positive infinity. It's just increasing forever. There is no precise number or value. So that would be kind of a description of the end behavior using limit notation. So this is kind of how you would maybe use function analysis on a problem. But notice how much we can answer, increasing, decreasing, positive, negative, domain and range, just from a picture. So I hope that this recording was helpful, and I hope that you're able to take these concepts and apply them to the functions and graphs that you're looking at in the future.